There is a river buried beneath Egypt that does not appear on any map. It does not show up from the ground. It has not shown up in over a century of excavation across some of the most studied archaeological ground on the planet. It took a satellite, pointed at the desert for an entirely different reason, to notice it was ever there at all. This is not a story about a new pyramid. It is a story about how much of the most examined civilization in human history has been sitting directly beneath researchers' feet, completely invisible for thousands of years. In 2024, a team of researchers working with radar satellite imagery was conducting what should have been a fairly routine survey. Radar satellites work differently than ordinary cameras. Instead of capturing visible light, they send signals down into the ground and read what bounces back, which means they can pick up on subsurface features that no optical photograph, no aerial survey, and no ground-level excavation had ever detected. The team was scanning a stretch of the Egyptian desert running roughly parallel to the Nile, in the region containing more than 30 pyramids, including Giza itself. The project itself was not designed to hunt for a lost river. It was part of a broader effort to apply newer satellite methods to already well-documented archaeological zones, largely as a test of what the technology could add to a picture everyone assumed was already mostly complete. Giza has been surveyed by British, French, German, and Egyptian teams for generations. Every visible surface feature within miles of the pyramid fields has been mapped, measured, and published in academic literature dating back over 100 years. If there was ever a stretch of ground where researchers might reasonably expect no more major surprises, this was it. What the radar data showed was a long, curving depression buried under the sand and agricultural land, stretching for approximately 40 miles. It ran directly alongside the very pyramid fields that have been studied more intensely than almost any other archaeological site on Earth. And it was not a natural rock formation, and it was not a modern irrigation feature. It was the unmistakable shape of a river channel, a river that does not exist today, that no map from any period of Egyptian history shows flowing through that exact path, and that nobody had ever confirmed was there. By the time the analysis team cross-checked the radar signature against soil cores taken along the projected path, the picture had stopped looking like a possible artifact of the imaging process and started looking undeniable. The sediment samples showed the layered composition typical of a riverbed rather than wind-deposited desert sand, exactly where the radar said a channel should be, and exactly where no channel was supposed to exist according to a century of prior scholarship. They named it the Ahmarat Branch. Before going further, it's worth understanding exactly how a satellite can see a river that has been gone for thousands of years, because the method itself is almost as remarkable as what it found. The technique relies on what is called synthetic aperture radar, carried aboard satellites that orbit the Earth, sending down microwave signals rather than capturing reflected sunlight the way an ordinary camera does. These microwave signals penetrate dry sand to a meaningful depth, and different subsurface materials reflect the signal back in subtly different ways, depending on their density, moisture retention, and composition. Buried sediment that was once riverbed behaves differently at a microwave level than the surrounding desert sand that was never submerged. To a human eye standing on the surface, or even to an ordinary aerial photograph, the ground looks completely uniform. To radar, it does not. The old riverbed leaves a kind of fingerprint that only becomes visible when you are asking the ground the right kind of question. This is not a new idea in the abstract. Radar-based subsurface mapping has been used before, most famously in the 1980s, when a similar technique revealed ancient, long-buried river channels beneath the sands of the Sahara in Sudan and Libya, channels that once supported entire river systems in a region that is now some of the driest desert on the planet. But applying this level of precision specifically to the stretch of Egypt containing the core pyramid fields, cross-referencing it directly against known causeway positions, is what made the 2024 findings so immediately significant to Egyptology specifically, rather than being a broader geological curiosity. Here is where the story stops being a curiosity and starts being something researchers had been quietly wondering about for over a century. One of the oldest unresolved questions in Egyptology is remarkably simple to state, and has been remarkably difficult to answer. How did ancient Egyptians move stone blocks weighing between 2 and 15 tons each, in quantities exceeding 2 million for the Great Pyramid alone, across miles of open desert, using only Bronze Age technology? The traditional answer has always involved the Nile. Historians have long assumed that blocks were floated on barges along the river and then hauled the final stretch overland on sledges, lubricated with wetted sand to reduce friction. Ancient Egyptian texts and tomb paintings support parts of this picture, including a well-known inscription describing workers pouring water in front of a sledge to ease its movement across sand. But there has always been a nagging problem with the theory. The modern Nile, and every historically documented course of the Nile, sits too far away from many of the pyramid sites to make a purely river-based transport method fully make sense. The final overland stretch, by some estimates, would have needed to cover a distance that seems disproportionately difficult, given how precisely and efficiently everything else about pyramid construction was engineered. The Ahmarat Branch changes that calculation entirely. If this now vanished channel was flowing during the Old Kingdom period, when the majority of these pyramids were built, it would have run directly past the base of the pyramid fields, cutting the overland transport distance down dramatically. Researchers cross-referencing the radar data with the locations of pyramid causeways, the raised stone pathways leading from valley temples up to the pyramids themselves, found something that should not be a coincidence if this branch is simply a natural fluke. A striking number of these causeways appear to terminate directly at the edge of where the buried river channel would have been. Not near it, not in the general vicinity, at the edge of it, as though whoever built these causeways was constructing them specifically to meet a functioning riverbank that, at some point in the following 4,000 years, quietly ceased to exist and was swallowed by the desert. Read that again. The very structures ancient Egyptians built to receive their stone shipments appear to align with a river that modern archaeology did not know existed until a satellite noticed a shadow in radar data. Consider what this means for one pyramid complex in particular. Several valley temples, the entry structures where funeral processions and construction barges alike would have arrived, sit at what researchers now recognize as consistent, specific distances from the mapped course of the Ahmarat Branch, distances that make far more sense as a former riverbank than as an arbitrary architectural choice. For over a century, Egyptologists have puzzled over why certain valley temples were positioned where they were, sometimes seemingly at an inconvenient distance from the pyramids they served. A missing river, sitting exactly where it needed to be, resolves a puzzle that had no fully satisfying answer before. It's worth pausing on just how many separate, independent lines of evidence had to align by coincidence for this to not be the buried river. Researchers now believe it is. The radar signature had to match the shape of a natural channel rather than a geological fault or modern feature. The soil cores had to show riverbed typical sediment layering rather than ordinary wind-blown sand. And the positions of the causeways, structures built by people who had no way of knowing a satellite would exist 4,000 years later, had to happen to line up with the edge of that same channel. Any one of these on its own could plausibly be dismissed as coincidence. All three together, pointing at the same conclusion from three completely independent methods, is the kind of convergence that tends to make even cautious researchers use words like compelling rather than possible. The name itself, Ahmarat, was chosen by the research team to reflect the river's now vanished status, and it has already started appearing in follow-up academic papers as the accepted term for the feature, the first step in a discovery moving from preliminary finding to established part of the historical record. That process, small as it sounds, matters. A century from now, students of Egyptology may simply be taught that the Ahmarat Branch existed and helped move stone for the pyramids, the same way today's students are taught that the Nile itself was central to ancient Egyptian life, without necessarily learning just how recently and how accidentally that fact was actually confirmed. But here is where it gets stranger. The Ahmarat Branch was not a small marginal waterway. Sediment analysis and core samples taken from the buried channel suggest it may have been comparable in scale to a significant tributary of the Nile system, wide and deep enough to have supported substantial river traffic, not shallow seasonal flooding. This was not a trickle of water that occasionally helped move a few blocks during flood season. This was, by some estimates, a genuine secondary branch of one of the most powerful rivers on Earth, flowing consistently enough to function as a primary transportation corridor for one of the largest construction projects in human history. And it disappeared so completely that not a single written Egyptian record, not a single hieroglyph, not a single administrative document from thousands of years of meticulous Egyptian record-keeping appears to explicitly describe its existence or its disappearance. A civilization famous for documenting nearly everything, from grain shipments to tax disputes to the precise dimensions of tombs, left no clear account of an entire branch of its most sacred river vanishing. The most likely explanation researchers have proposed involves a combination of natural processes playing out over an extremely long timescale. Gradual climate shifts across North Africa, well documented in other contexts, slowly reduced regional rainfall and altered the Nile's flow patterns over thousands of years. This period, sometimes referred to by climate researchers as the gradual drying of the African humid period, saw what had once been a noticeably wetter Sahara and Nile Valley region slowly transition toward the arid landscape recognizable today. Wind-blown sand moving consistently in the same direction for millennia would have slowly buried a channel that was already losing water volume, burying it deeply enough that by the time later Egyptian dynasties were building and rebuilding along the Nile, the Ahmarat Branch was already gone from living memory, let alone from the written record. In other words, the disappearance was not sudden. It did not happen in a way that would have looked like an event worth recording. It happened the way most true disappearances happen, slowly enough that by the time anyone might have thought to write it down, there was nothing dramatic left to describe. Just dry land where a river used to be, indistinguishable to the naked eye from any other stretch of desert. That fact alone should unsettle anyone who assumes the written historical record captures the important things. It does not. It captures the things someone happened to think were worth writing down at a moment when they still seemed noteworthy. A slow-motion geological disappearance, stretched across many human lifetimes, apparently did not qualify. But here is where the story becomes something bigger than one buried river. If a feature this large, this significant, and this directly tied to the greatest engineering achievement of the ancient world could remain completely undetected until a radar satellite happened to notice it in 2024, the obvious and uncomfortable question is, what else is still down there? Egypt's landscape has been surveyed, walked over, dug into, and photographed more than almost anywhere else on the planet for over 2 centuries of organized Egyptology. And still, one of the most important physical explanations for how the pyramids were actually built was sitting a few meters underground, invisible to every method except one that did not exist until recent decades. Radar satellite technology capable of this kind of subsurface imaging has really only become widely usable for archaeology within the last 20 to 30 years, and the specific techniques used to identify the Ahmarat Branch are newer still, which means the entire history of Egyptology, from the earliest excavations in the 1800s through most of the 20th century, was conducted without any ability to see what was directly beneath the sand outside of wherever someone happened to physically dig. Entire theories about transport routes, settlement patterns, and construction logistics were built on a picture of the landscape that, it turns out, was missing an entire river. Researchers involved in the discovery have been notably careful not to overstate what comes next, and for good reason. Confirming the full path, the exact dates the branch was active, and its complete relationship to individual pyramid construction projects will require years of additional core sampling, radiocarbon dating of sediment layers, and cross-referencing against other satellite passes. Science moves carefully here, as it should, but the initial mapping alone has already done something significant. It has demonstrated conclusively that a waterway large enough to reshape our understanding of pyramid construction logistics was sitting completely undetected in one of the most intensively studied landscapes on Earth. And Egypt's desert stretches for hundreds of thousands of square miles beyond the specific corridor this survey covered. Think about what that means. The technology that found the Ahmarat Branch has, so far, only been applied to a relatively narrow strip of territory, chosen specifically because of its proximity to known pyramid sites. The vast majority of Egypt's desert, including regions with far less archaeological attention than the Giza Plateau, has not been subjected to this kind of subsurface radar analysis at all. If a river this significant could hide in the most heavily scrutinized stretch of ground in Egyptology, there is no reason to assume the surrounding desert has given up all of its secrets simply because nobody has pointed the right instrument at it yet. This would not be the first time satellite radar rewrote an assumption archaeologists had settled on generations ago. Similar techniques applied elsewhere in the world have revealed entire buried settlements beneath Cambodian jungle canopy, hidden road networks beneath Central American rainforest, and now an ancient waterway beneath one of the most photographed landscapes on the planet. In Cambodia, LiDAR surveys conducted over Angkor in the 2010s revealed an entire medieval city grid, canal systems, and urban infrastructure that had been completely reclaimed by jungle growth, invisible from the ground, and even from ordinary aerial photography, hiding in plain sight beneath tree canopy that archaeologists had walked through for decades without realizing an entire city's road network was directly beneath their boots. In Central America, similar LiDAR work over Guatemala uncovered tens of thousands of previously unknown Maya structures, effectively expanding the known scale of Maya civilization almost overnight, using a single set of flights over terrain that had already been the subject of a century of ground-based fieldwork. Each of these discoveries shares the same unsettling shape, something enormous, something structurally important, sitting in plain sight in every sense except the one that actually mattered, waiting for a tool capable of asking the ground a question nobody had known to ask before. The pattern is consistent enough now that it raises an uncomfortable methodological question for the entire field of archaeology. How many of our current, confidently taught historical narratives are built on landscapes we have only ever examined with the wrong instrument for the job? There is also a more immediate and more practical layer to this discovery that goes beyond archaeological curiosity. Understanding where ancient river systems used to flow has direct implications for modern Egypt, a country facing serious and worsening water scarcity, heavily dependent on the Nile for a population that continues to grow past 110 million people. Mapping ancient buried channels can inform hydrological studies, groundwater research, and even agricultural planning in a region where every additional insight into historical water systems carries real, present-day weight. Some hydrologists studying the Ahmarat findings have noted that buried ancient channels can sometimes still hold residual groundwater reserves, meaning a discovery framed as being about the distant past turns out to have direct relevance to decisions being made about Egypt's water future right now, in a period when Nile water rights are already a source of serious regional tension between Egypt, Sudan, and Ethiopia. The researchers who identified the Ahmarat Branch were not looking for it specifically. They were conducting a broader survey, applying a relatively new technique to a well-studied region, mostly to see what the method could reveal. What it revealed was a river-sized gap in over a century of careful, methodical scholarship. Not because anyone had been careless, because the tool required to see it simply had not existed until now. That is the part of this story that deserves to sit with you longer than any single fact about pyramid transport logistics. It is not really a story about ancient engineering, even though it solves a real piece of that puzzle. It is a story about the limits of observation itself, about how confidently a field can describe a landscape, publish theories about it, teach it to students for generations, while a river-sized feature sits directly underneath the entire conversation, waiting for the right kind of instrument to finally notice it was there. The sand did not hide the Ahmarat Branch on purpose. It simply did what sand does over thousands of years, settling grain by grain until an entire river became indistinguishable from the desert around it. Nobody chose to forget it. The conditions for remembering it never arrived until a satellite, scanning for something else entirely, happened to look at the ground in a way that could finally see what was already there all along. The real question this leaves behind is not simply how the pyramids were built, even though that question is now closer to an answer than it was before 2024. The real question is how much of the rest of ancient Egypt, and how much of every other extensively studied ancient landscape on Earth, is still sitting exactly like this. Fully present, fully real, completely invisible. Not lost in the way we usually imagine losing something, but simply unseen, waiting for whichever tool eventually exists that can finally notice it is there.